Hi everyone, this video is going to finally put together some concepts for us, like how exactly electrons and light are related. We've talked about electrons and where they go in like a Bohr model, and we've talked about visible light on the electromagnetic spectrum, and it's time to put these concepts together. So we're going to start with just an arbitrary Bohr model. Let's say it has 3 electrons on it, and we're going to look at what happens to that electrons when they get rid of energy. So let's say we have an electron here. We will randomly select this electron. So we want to know when that electron absorbs energy, what is going to happen? So if we have this electron that we've chosen and it absorbs energy, so we're going to draw like a lightning bolt for it to absorb some energy. This electron is not going to stay put. This first energy level can only hold a finite amount of energy. And if it absorbs energy, it's going to have to go somewhere else. So it might go up, depending on how much energy it absorbed, to a different energy level. It might go to the second one, it might go to the third, fourth, fifth. For our understanding right now, we're going to keep it simple and say that it just jumps up to the second energy level. So when an electron absorbs energy, it is moving from its ground state and now it's about to move up to its excited state. It's gone from low energy to now it is existing with higher energy. So this electron has moved up to a different energy level. However, here's the thing. Electrons don't like to stay up at this excited state. That electron is going to fall back down. So this electron we're looking at, it's not going to stay here. It doesn't want to stay at an excited state. It wants to be back at its ground state. So it's going to fall back down to this first energy level. However, something special happens when it falls back down. When an electron goes from this excited state to the ground state, it is going to emit energy as visible light. So when an electron then releases energy, when it falls back down, it goes from this excited state back down to the ground state. So it's back where it wants to be at the ground state. So right here, we had the electron at the excited state. And then when it fell down to its ground state, it emitted energy, but specifically as visible light. And that visible light, we know, the only part of the electromagnetic spectrum we can see, has a particular color that goes with it. So as the electron falls back down, it releases energy as visible light. And that visible light has a color, and the color of the light is going to be unique to each element. And this is where we can kind of see these two ideas starting to come together, electrons and light. Every single element is unique, and it has a unique number of electrons and a unique way that these electrons are configured. So when these elements get certain amounts of energy added to them, their electrons start to go up to this excited state, and then they fall back down to the ground state, and they are emitting visible light. And so what we can do, because each of the colors is unique, is scientists can identify an element then based on the color of light that it emits. So every single element, all 118 of them on the periodic table, when they absorb energy and then release energy, they emit particular colors of visible light. So what we can do is we can examine this light to figure out what's going on. For example, we have a tube of hydrogen gas, and then there's an electric current being passed through this tube. So kind of think of like a neon light, right? There's electricity being passed through that tube, and then it starts to glow. And all of those electrons in the hydrogen tube, they are jumping up from their ground state to an excited state and then falling back down. And as they fall back down, they are emitting light that's a particular color. So hydrogen does look like that. It's this nice magenta color. But we can take that really nice color and we can put it through a prism, and that prism will break apart our light based upon wavelength, because we know that visible light gives us its color based upon its wavelength. And then the colors get plotted along an emission spectrum. And an emission spectrum is unique to each element. It's unique to each element. So no other element on the periodic table looks exactly like this. So hydrogen gets particular bands of color at particular wavelength measurements. And really, when we look at the lines like this, and we can see the lines, we're really technically looking at a line emission spectrum. And we can look at a couple different ones. We've got hydrogen here, helium, and then iron. So iron's very bright. Here's a picture of the periodic table if they were all seen through emission spectrum. So we can see we've got lots of bright colors in there, and you'll notice that some of it's not filled out. That's because those are man-made elements, and the isotopes just don't last very long to even get an accurate emission spectra from. The practical application for us is we could take a look at the color of light that's given off by different stars or galaxies that are just millions of light years away, and if we pass it through a prism, we can look at the line emission spectrum and figure out what exactly that star is made of. And so this is the explanation to one of our guiding questions for the unit of how can we tell what a star is made of that's millions of light years away? Well, through a telescope, we look at whatever color it's emitting, and then we can break apart the color into its line emission spectra, and then we can match it to our known elements on the periodic table, and then we can say, well, hey, this star is made of hydrogen and helium. On the flip side, you guys might also see, instead of a line emission spectrum, you might see something called line absorption spectrum. Really, it's just kind of the opposite of this. So instead of like the background being black and then seeing like the different colors that show up, its background has the full spectrum, and then you might just see like bands of color are missing, and that would be the absorption spectrum, just in case you hear that as well. All right, so now you guys know what the relationship between electrons and light looks like. We know that as an electron absorbs energy, it goes from the ground state to excited. It doesn't want to stay there. It falls right back down and releases energy as visible light. And we can look at that light and analyze it in terms of its line emission spectrum, which is unique to every single element. That is it for notes about electrons and light.